Hello, my name is Dr. Nicholas Dogris, and this is a video demonstration of the NeuroField real-time Z-score procedure. We recently released two new sets of hardware here at NeuroField Incorporated, one of which is a 19-channel EEG amplifier that we call the Q20. We also released a new EMF stimulation unit that we call the X3000 Plus. If you go to neurofield.com, you can see more information about both of those units. The NeuroField Real-Time Z-Score procedure is a two-pronged biofeedback entrainment procedure. It is designed to guide the brain into a normative level of functioning using EMF and audio operant conditioning rewards. Essentially, the way the protocol works is a EMF pulse is given, like it is now. When you see those little lights turn on, that means a pulse is being given. And it's given for a specific amount of time, and then it shuts off. And then 19 channels of EEG data is measured for 4 seconds. That data is immediately processed by the 19-channel Z-score database, and Z-scores are generated. Now in the program, we can set up thresholds to monitor all 19 channels across 10 different frequency bands that the NeuroGuide Z-score database allows us to monitor. You can set up the Z-score criteria any way you want, and in this particular case we have set it up to follow the normative range, which is basically 1 to -1. So when a Z-score is generated that falls within the 1 to -1 range, after we give an EMF pulse, NeuroField will then give a reward tone to the person. Now that's the operant conditioning side of the method. So essentially, an EMF pulse is given, 4 seconds of EEG is recorded, Z-scores are generated, and if the Z-score falls within the threshold range that you set, then a reward tone is given. What we also learned about EMF several years ago was that the brain will copy or mimic low intensity EMF. So if you feed in 10 cycles per second, the brain will start generating a peak frequency at 10 cycles per second, 15 cycles per second, and then you'll start to see 15 cycles per second peak frequency generated in the EEG. The amplitude will increase. Well, this is very interesting to us because in regular operant conditioning neurofeedback, it can be very difficult to increase the amplitude of a deficient frequency band, for instance like beta. So we began giving beta at 15 to 19 hertz, and the way NeuroField does it, it starts at 15 hertz and it'll give it for X amount of seconds, and then it'll shut off and measure EEG. If beta increases into the normative range from 1 to -1, then a reward tone is given, and NeuroField will give 15 hertz again. However, if the Z-score that's generated does not fall within the normative range, then NeuroField will modulate, and it will give 15.1 hertz essentially, and conduct the same test again. If the Z-score falls within the normative range, then 15.1 hertz would be given again. If not, then NeuroField will modulate again to 15.2 hertz, and so forth until it reaches 19 Hertz. Now, as you watch this program run, we are monitoring thresholds set at F3 and F4 for beta, and P3 and P4 for alpha. Now, with this particular person, we had conducted a QEEG, which is what we do with everybody that comes for treatment at my clinic. And we conduct a clinical interview and develop a conceptualized understanding of the person's complaints and presentation, along with the physiological EEG data that we collect. In this way, we match up the numbers to the person, and we get a really good sense of how the person functions and what it is that they need, which is a very comprehensive approach to treatment, and very unlike standard psychiatric treatments in which a simple medication could be given based on presentation. We do conduct the QEEG so that we do have the appropriate data to determine what is really happening with the brain. Now, the RTZ approach will affect the brain immediately, and which is why we developed it in this way, simply because it is a very rapid treatment method that can have a treatment result within minutes after starting the program. The data that is obtained throughout this RTZ treatment procedure is available for analysis, and we give you the option of being able to dump that data to a text file so that you can examine that data in our program that we call NeuroPlot. And after this procedure is finished, I will show you what that looks like. A treatment session can last anywhere between 15 minutes to 45 minutes. Typically, we find that the RTZ procedure has a clinical impact if it's given within that time frame. But typically, in my clinic, the average session time can be anywhere between 30 and 45 minutes. When we do intensive treatment with people, we give this procedure in the morning, and then in the afternoon we give the NeuroGuide 19-channel surface or Loretta 19-channel neurofeedback treatment to a person. This two-pronged intensive treatment approach can have remarkable clinical outcomes and effects within a pretty short period of time. I like to do this for a total of 2 weeks, and by the end of those 2 weeks you can see marked changes in the data and in the person. The procedure is almost done here. When it gets all the way done, then the screens will shut off and clear, and it'll give us the opportunity to be able to dump the data to a file. Okay, and that's the post-test EEG recording there. So now I'm going to dump the data. This is the Z-score data. I'm going to dump it. You can examine the data here in NeuroField, but it's easier to do it in NeuroPlot. But if you need to see it immediately, you can see it with this window. So let's go over to NeuroPlot. And here you can see what treatment effect occurred during the treatment. Now, we have a program that we call NeuroPlot, and in NeuroPlot we monitor all 19 channels of EEG data across 10 different frequency bands that the applied neuroscience DLL monitors. In the plot, you can see on the vertical axis the z-scores, and on the horizontal axis you can see the stim cycle or stimulation EMF cycles that we gave to the person. So we're looking at each one of the brain's responses to each one of the stimulations that it received. And there is a trend analysis line that is drawn through the plot, so you can see the direction of the z-score from the beginning of the session to the end of the session. Now here we are monitoring beta absolute power, and in this particular person beta was low, and so we can see that the z-scores did increase for beta from the beginning to the end of the session, which is good. And you can look at, now we have beta loaded up here, so we can look at each one of the particular channels. Channel 1 is FP1. We're going to put the actual EEG site names in there soon. But channel 1 is FP1, and so I'm not surprised to see that beta did increase at FP1. And for this particular person, that's exactly what we were shooting for. So as I cycle through each one of the channels, you can see what the result was as the treatment progressed. And the goal is to be able to get to a Z of 0, is to shoot for a Z of 0. The brain will naturally recalibrate itself and normalize itself if it's shown how to do so. And so it's very rare that we actually see a trend that goes in a direction that is outside of the normative range. It usually corrects pretty quickly, and that's a good example of one right there. So this concludes the Z-score RTZ procedure video demonstration. Thank you.